In computing, data structures are essential tools for organizing and managing large amounts of information within a program. A data structure is a specialized format for storing and arranging data so it can be accessed, manipulated, and processed efficiently. By consolidating related data into one place, data structures simplify the complexity of programming tasks and enable the creation of efficient and effective software. Instead of handling numerous individual variables, a programmer can use a data structure to store and organize a collection of data, making the code cleaner, more readable, and easier to maintain. One of the simplest and most commonly used data structures is an array. An array is a collection of multiple data values stored under a single name. Each value in the array is assigned an index, which serves as its unique identifier within the array. These indices allow individual elements of the array to be accessed or modified quickly and directly. For example, in an array that holds the numbers 5, 10, 15, 20, the first value, 5 would be at index 0, the second value, 10, at index 1, and so on. Arrays are particularly useful when working with large amounts of similar data, as they eliminate the need to create separate variables for each value, thereby reducing redundancy and improving the overall efficiency of the program. Arrays can store data of the same type, such as integers, floating point numbers, or strings, depending on the requirements of the program. For instance, an array could hold a list of temperatures recorded throughout a day, such as alter 15.5, 16.8, 18.2, 19. Or it could store a series of names like Alice, Bob, Charlie, Diana. This uniformity ensures that all elements within an array are compatible, making operations like sorting, searching, or iterating through the data straightforward. In many programming languages, arrays are defined with a specific size, meaning they can hold a fixed number of elements. This limitation can be advantageous when the amount of data is predictable, as it allows the program to allocate memory efficiently. Arrays are also invaluable for performing repetitive tasks with data. By combining arrays with iteration, such as a for loop, a programmer can process each element of the array in sequence. For example, if an array contains a list of test scores, a for loop can be used to calculate the average by summing all the elements and dividing by the total number of values. This approach is not only concise, but also scalable, as the same loop will work regardless of the array's size. While arrays are a fundamental data structure, they can be extended or adapted for more complex tasks. For instance, multidimensional arrays allow data to be organized into grids or matrices. A two-dimensional array, for example, can represent a table of data, where one dimension corresponds to rows and the other to columns. This is particularly useful in applications like spreadsheets, game boards, or image processing, where data naturally forms a structured grid. Accessing elements in a multidimensional array involves using multiple indices, such as array, to access the element in the second row and third column. Data structures like arrays provide a way to store and organize large amounts of data efficiently, enabling programmers to manage complexity and improve the performance of their programs. By consolidating multiple values into a single entity, arrays make it easier to work with collections of related data, whether for basic operations like retrieval and modification, or more advanced processing tasks. They are a foundational concept in programming and serve as the building blocks for more sophisticated data structures, ensuring that programs are both powerful and efficient.